You're listening to Productivity Protected, the podcast that's all about data privacy and security. We'll unpack emerging threats, hot issues in data security, and top ways to protect your data and how you work. Here's your host, Spencer Kupferman.
Welcome back, everybody. I'm Spencer Kupferman, your host for this fantastic episode. Every episode we have is fantastic. In every episode we always have very special guests. We are going to talk today. We're going to do something we don't usually do on Productivity Protected Podcast. What we don't typically do is talk about roughly the same platform or same issue or same story in back-to-back podcasts. But since the feedback has been overwhelming as we talk about the mainframe, the IBM mainframe, we talk about our PK Protect ZOS platform. We're going to keep going with that. We've got a lot of feedback from our customers. Of course, I want to give a shout out to our loyal customers out there, our prospects who are getting ready to do business with us, our partners who we love. Happy holidays to all of you out there. So we're going to go with that theme. I'm going to want to give a shout out to my good buddy, Dusty Rivers from Mainline Tech, who kind of got this started on our previous podcast. Dusty and I had a great chat about IBM mainframe, one of our strategic partners, Mainline Technologies. Check them out if you haven't already. I want to give Dusty a shout out here. And we're going to continue, as I said, with this theme today. We've got a very special guest. I want to get into introducing our special guest. And this special guest is part of our community. He's part of the PKWARE community. He's worked at PKWARE. By the way, he has worked at PKWARE not once. He has worked at PKWARE twice. This is his second tour of duty here at PKWARE. I'm talking about the world famous IBM system genius, extraordinaire, visionary, whatever you want to call him. Tate Hamill is here with us. Of course, he's our director of product management for all IBM systems that we handle at PKWARE. And I'm thinking, I've got all these other guests. I got guests from IBM. Where is Tate? Why hasn't Tate been on the Productivity Protected podcast? And I am so thrilled. Finally, he's made time for us here. So excited to have him. Looking forward to jumping into all this great IBM mainframe stuff, certainly as it's related to PKWARE Protect ZOS. Let me give some background. How about that? Let me give some background on our special guest here. Of course, Tate fancies himself a computer nerd, so he wanted to make sure that we said that loud and clear for our millions of viewers out there. And Tate learned BASIC. We're going to go back now. We're going to go back, a little history here. Tate learned BASIC on the Commodore 64. For all of you Commodore 64 folks out there. And that was back in sixth grade. That was in sixth grade. Of course, I will not make that claim. In sixth grade, I think I was playing dodgeball and kickball all the time and getting thrown out of my classes. But Tate certainly wasn't. He wrote his first game on an IBM personal computer in 1985, ladies and gentlemen, 1985. That was shortly after War Games. He went on and ended up getting a degree. He spent some time at IU at Indiana and also Wright State. Tate's a Midwest guy. He lives in the great city of Dayton. That's the great state of Ohio. He's a big Ohio guy, very proud of his lineage there. But his degree is very applicable. I want to point this out. It's very applicable to his mainframe status and knowledge as a biology and English major. So go figure, right? How does a biology English major end up becoming a computer IBM extraordinaire, platform extraordinaire? I'm going to let Tate tell you that story. But he spent a lot of his high school years in college in speech and debate tournaments, which you'll be able to tell he's enjoys public speaking. He's good at it. He's a great advocate for PKWARE, a great ambassador for IBM platform, and like I said, loves public speaking. Coaches a debate team, and just he's very focused on his skill set around presentation, and I think that'll become very evident. I did mention he was a two-tour player here at PKWARE. Joined us in 1996. I graduated college in 96. He joined PKWARE in 96, stayed till 2004, and then came back to us because we're just so good. He just couldn't stay away from us. He came back to us February of 21, and here he is today. And he spent many years kind of really organically, if you will, learning the system, meaning the mainframe and the PKWARE system, and then really getting exposed to mainframe and just falling in love with it. And so without further ado, I want to welcome our very own, proudly, PKWARE's very own, Tate Hamill to Triple P, baby, the Triple P podcast. Welcome, Tate.
All right. Well, thank you very much, Spencer. Appreciate that introduction. And, I will say, seeing such famous people like Dusty Rivers, Lynn Santa Lucia, and even IBM's Meredith Stowell on your productivity podcast has made me very envious. And I was very pleased to finally get an invitation to come out here and tell you all the great things that are happening at PKWARE. So, first of all, appreciate the invite. And yeah, I tell you, my love for the mainframe was extremely organic. Definitely a computer nerd. Growing up, learned BASIC, learned C++ as well. Wrote my first game back in the 80s, but it was finally, I was working tech support at PKWARE, and I had to support the mainframe product. And mainframes were just something that you saw in movies, right? And I finally got exposed to it, and I just had never been exposed to something so powerful and so really prestigious when it comes to its place in the corporate world. So so all that was extremely organic, and absolutely loved PK Zip, the product, and it came out in 1989. I knew about it back then before I even started working for PKWARE. And the fact that it was sitting on the mainframe and I was able to immediately start messing around with it. Like I said, it just, it really, I think it cemented my love, not for just the mainframe, but I love doing all this stuff for PKWARE, and I've become a very huge advocate for all things mainframe and all things PKWARE. We make fantastic, brilliant products that our customers still love to use and been embedded for the past 30 plus years. So it's an honor to be here. It's an honor to be back, and couldn't be more thrilled to be represented on this podcast.
Appreciate that, Tate. And we feel the love. Let me tell you, your energy is contagious to all of our colleagues at PKWARE. Of course, your knowledge goes without saying. But tell us, if we can, tell the audience, I think they'd love to hear, how does one go from an English biology major and then end up in the technology realm? Of course, I guess you were destined for that since your sixth grade Commodore 64-bit. But just give us a short little history on how you go from that major into these platforms.
Yeah, absolutely. Well, I mean, obviously there's not a real direct connection, except that when you graduate with a degree in English and biology, and you're pretty sure that you wanted to be a doctor at one point in time, but that kind of fell off to the wayside. So I was kind of like, all right, so I've got this degree, I'm not exactly too sure where I'm going with it. I need a job. And so while I was contemplating what I was going to be doing with the rest of my life, I happened to fall into this awesome computer job for a company that I already knew about, for a product that I already used. And it was just somehow became a natural fit. And I guess I can say that I'm one of the most fortunate people that I know, that I work in a job that I absolutely love, right? It was my hobby. And now I get to do this. Somebody pays me to do this now, which I mean, how extraordinarily fortunate am I? So so that's, it was kind of like blind luck almost. I needed a job, and I happened to be at the right place at the right time. And here I am today.
That's great. That's great. And I also, you said at the beginning, you'd name some of these other, we'll call them IBM luminaries, who had been on our podcast. And that told me right off the bat that you are a fan. You've been a fan of the Productivity Protected podcast, of the Triple P podcast for some time, watching all these great IBM luminaries. And like you said, now you get to be here yourself. So good for you. And thank you for joining us. I want to give a little, maybe we'll call it a preamble or just a little history here for the audience before we jump in to the Q&A here, Tate. But for really the last 60 years, a lot of people don't know that. IBM, the platform, the world's largest enterprise and governments have relied on the IBM mainframes to carry their most critical workloads. And so you're talking about a legendary machine that's accomplished so much over decades and decades. And so whether it's industries, whether it's banking, a lot of our customers, as you know, Tate, you work with them firsthand, but banking, insurance, financial services, government, retail, really some of the largest consumers of PII, personal identifiable information, or as we call it in the space, PII. I mean, the challenge is exacerbated when application developers copy production data for development and testing purposes, et cetera, and thereby duplicating, replicating, and proliferating sensitive data across the enterprise to support all sorts of different types of mission critical applications. And so with that preamble, if you will, on the IBM mainframe, we kind of go and transition into the PK Protect for z/OS, which uses a patent pending, if I can say, a patent pending technology that we call SchemaLink. For those of you who have heard it, our customers out there who have already spoken to us, and for those who are interested, you know how to get a hold of us. Tate's here. We'd love to have you. But what it does is accurately peers into unstructured data sets and apply over 150, that's right, 150 out of the box or customized policies to its discovery criteria, and then searches for that sensitive PII, as I mentioned before, PII, highly classified confidential information, wherever it resides, wherever it lives. So that's what PK Protect for z/OS does. Of course, Tate, who is our product manager, director for that, who spearheads that entire effort, has spearheaded rather that entire effort. We're lucky to have him here today. So I want to jump right in, Tate. I want to jump right in. We got a lot of people want to learn about this because we think we got something. We know we have something here that others just don't have. We've cracked a code that others haven't cracked, and we've solved a problem that others haven't solved, and we want the world to know about it. I'm going to let you have the chance to tell the world about it. Here's how we're going to start. There is a lot of conversation out there, Tate, certainly since the share, that's kind of the IBM mainframe Super Bowl conference about the SchemaLink technology. And thankfully there is. I've heard you talk about how the PKWARE engineering team has solved and unsolved, how we have solved this unsolved, or what was maybe thought about to be an unsolvable problem. We've solved it in the industry. First, if you can, just describe what that unsolved problem is. People want to know what was so difficult. What was this unsolved problem on the z/OS that PKWARE's engineering squad has managed to solve? Could you start us off with that, please?
So when we talk about mainframe data sets, the mainframes comprise, outside of databases, it's largely unstructured data. But because the mainframe speaks kind of a funny language called EBCDIC, and you got all this data that sits in this binary format. So you got these mainframe data sets that are essentially streams of unstructured binary data. And so it becomes impossible to actually read that data without some assistance. And usually that assistance on the mainframe comes in the form of like a data definition, such as like a copybook. It would be similar to like trying to read an Excel file or a Word document without that Microsoft application, right? It would look like just encoded garbage on a screen, right? So that's why you need the actual, in this case, the application to be able to read it. So it's the same scenario on the mainframe. Kind of hard to read these data sets without actually having the application standing behind it. So then the question becomes, if you can't read the data, how can you find anything in it, right? And so this goes to the question of, well, in our scenario, how do you find sensitive data if you cannot read this data set, right? And so PKWARE has spent the last 3 years in the engineering labs, in the bit mines, solving this very problem. All right. And we did that with a piece of technology said as patent pending called SchemaLink. And we can definitely get into how that all works. But we solve this problem of being able to find the sensitive data in these streams of unstructured binary data. We did it. And it wasn't an easy task, but it's something that we're extremely proud of.
Oh, that's great. And that's it's fascinating. And you're right. There was a lot of trial and tribulation to figure that out. Of course, that's a credit to you and our team here at PKWARE, who arguably really are second to none in the industry from a mainframe perspective. And we really, IBM platforms, you'd mentioned the history of PKWARE in general, really where we kind of, it's where we really earned our stripes early on. So taking this journey full circle here and now solving this challenge it's a monumental feat. And now we're experiencing, of course, the fruits of that labor. As I said, overwhelming responses to what we've been talking about for a while, which is this capability. So let's drill down on that if we can, Tate. So as I said, this is very interesting, very fascinating. Certainly, again, for all of our mainframe listeners, very fascinating for them. Because I was fairly certain that there were other solutions. I mean, that was the question. It's like, who else is kind of doing this? And so other solutions on ZOS that are able to scan for sensitive data. And so doesn't this imply that they solved this issue as well? Because there is other solutions that potentially scan for sensitive data. Just give us a clarification and really specifics around where that differentiator exists.
Yeah, absolutely. So, I mean, completely fair question. I guess first and foremost, when we talk about enterprise-wide solutions for doing discovery on sensitive data, while they're, that the space is relatively crowded. However, there are a lot of software vendors out there that say that they can do this, but what is often missing, and I'm going to say overwhelmingly what is missing from these offerings, is a mainframe solution, right? You might do that. You might be able to do sensitive data on endpoints or in cloud shares or a database. And again, that's a fairly common thing. But to be able to do it on a mainframe, there's only a few of us out there that even make this claim, all right? So first and foremost, we can probably eliminate about 95% of the competition out there from not even actually having a legitimate mainframe solution. Now, for those that are still in the ring at the end of that, once we get that filter applied, so what's left? Well, the solutions that are out there, and there's really only about 2 of them, they do what's called a proximity search, all right? So just like I told you, they don't really know how to read the data. So they start going through the stream of data byte by byte, and they think they come across like a 12-digit number, all right? So then they go, well, is that a credit card number? Yes or no? They can't answer that question, so they have to look in front of that record and after it and look on top and below. And they do what's called this proximity contextual search. They try to find context that says, hey, that 12-digit number is surrounded by a billing zip code, a first, last name, and a date of birth and a social security number, something like that. And that's how it corroborates that 12-digit number stands a good chance of being a credit card number. All right. But the problem is, Spencer, they don't know. All right. That's the real differentiator. They don't know what they're actually looking at. They kind of have to guess. And then they try to find corroborating evidence that what they guessed at is in fact the correct thing. That often gives you a lot of false positive hits, confidence factors that are through the floor. It's not really good. They aren't great results. So if your results aren't great on the mainframe, then why are you bothering to use the solution, right? If it's not giving you what you're looking for, right? And that's the differentiator. we actually know how to read your data sets. This is what sets us apart. We don't guess. We know explicitly how to read your data sets because we've got SchemaLink. And SchemaLink, for a lack of better word, Spencer, is kind of the magic beans behind how this all works. This is what we've spent the last 3 years in the bit mines innovating, trying to figure out, and this is the problem that we've solved. PKWARE with PK Protect for ZOS with SchemaLink Technology has the ability to, number one, find all your data definitions and COBOL copybooks, etc., and we then use those during the scanning process at runtime to find that sensitive data. So we actually know explicitly that 12-digit number that we just found is in fact a credit card or a social security number, or that this is a first and last name. We don't have to guess. We jump right to where that position is in that stream of binary data. And what that does from a performance standpoint, less CPU, significantly less IO. So not only is it accurate, but it's better for your system. PKWARE's done an incredible job of solving this particular problem. And that's what separates us, or what makes PKWARE's PK Protect really a market differentiator from what is out there in the marketplace.
Love to hear that. Guessing is not a strategy, certainly in cybersecurity. We cannot afford, vendors can't afford to be guessing, certainly around sensitive data, data sets, whatever flavor. Guessing is not a strategy and should not be one. And I'm glad that's not ours. Thank you for articulating that differential between us and everyone else here. And I think people are starting to, if you're listening in here, which I hope everyone is, you're starting to get a sense for the specialness of this capability. Of course, like you said, being in the bit mines for 3 years, we've learned a lot around this, and we're now putting that to practice for the betterment of really the entire IBM mainframe community. And so that was a great analysis. We're gonna keep going. So it doesn't sound like PK Protect uses this kind of, as I said, guessing proximity approach to sensitive data discovery, and thankfully we don't, thanks to folks like yourself and others. We talk about differing from this, I guess, this proximity search technique. Maybe be a little more. Why don't we get into the proximity search technique, and even if you want to reemphasize some of the points you made earlier, I think it's important to drive this differentiator home, but around the proximity search technique, which is really fast. It should be fascinating to all of the mainframe community to hear about.
Yeah. So so as you alluded to, I started talking about a little bit about SchemaLink here. So what makes PK Protect for ZOS better than what's out there in the market, right? How do we, it comes back to solving the unsolved problem. We originally described the problem, so we met with IBM, all right? And IBM sat down and talked to us about this problem they are experiencing. And we will highlight vSAM datasets as an example. There's literally no precise way to accurately scan a vSAM cluster without copybooks, all right? And so the problem that is experienced, Spencer, when we're talking about copybooks, is that, often in a mainframe data center, you're talking about being responsible for anywhere between 200 to thousands of applications running on a mainframe. And all those applications, those are all homegrown applications written in COBOL and assembler and Rex and PL1, etc. Right? And all of those have to have an application developer or several writing those applications, right? But the problem becomes that sometimes those development environments can be scattered. They also could be not using copybooks, but rather using an inline process to write the data, right? So what you end up having here is you have this very mixed development environment where not everything is easy to find or easy to get to. So what we've done, what we have been able to do with SchemaLink, this thing that makes us better, what sets us apart from everyone else, is that we've created this process that allows you to go out and actually find all the data definitions. And again, as an example, COBOL copybooks associated with your application. And then we can create schemas that we use at runtime to read your data sets. So again, when we're talking about this unsolved problem, very difficult to look inside of a vSAM cluster. But now that we know how to read the data set, because we've got your COBOL copybook and we've turned it into a schema, we now can explicitly walk through that data set, jump from one position to another without actually having to read the entire data set. All right. So again, it makes it efficient, significantly less IO activity. And again, it's precise, it's accurate. There is no guesswork, which makes our confidence factors on our search results, they're essentially through the roof. They're all staring at 75% or higher, with most of them sitting in the 90s or 100. So again, it's explicit, it's precise, there's no guesswork. And guess what, Spencer? That makes for awesome audits, right? Because now you can tell your auditor explicitly what type of data you have and where it's located. It's something that they cannot do today. And that's what PK Protect for ZOS with SchemaLink Technology is going to be able to do that nobody else can do today.
And just to clarify, and that all makes sense, and I appreciate that. And just to clarify, I play devil's advocate sometimes, so I just want to clarify for the folks who are listening in. So I guess couldn't everyone they can just use their own data definitions and copybooks for sensitive data discovery? Could they not just use their own? I guess. Go ahead.
No, I mean it's a great question. It really is. So I'm going to share something with you here. So I was talking about the complexity of these development environments, and you can have things scattered across different systems, etc. But when it comes to doing what SchemaLink does, right? So we can, we say that, roughly 90% of all the data sets on the mainframe are associated with applications, right? It's very similar to what we have on the PC. Most of the files we have on our laptops are created by Word document, by Word or Excel or some application, right, that writes those files for us. So just like that's the scenario for a smaller laptop or Windows environment on the mainframe, these data sets, I said they're typically complex data sets written by multiple COBOL applications, multiple copybooks, nested copybooks, all that good stuff, right? Well, what happens is that you can have the amount of time that it takes to do what SchemaLink does, to map data sets using data definitions, COBOL copybooks, can take a significant amount of time. I'll give you a great example of this, Spencer. Very first POV that we did, it was a data risk assessment for a large financial institution. They actually just wanted to focus their attention on this POV on just a small transactional application, a very important one, but it only managed about 20 vSAM clusters. And it took us 2 weeks to manually map these 20 vSAM clusters. 2 weeks for just 20 data sets. Now, I'm going to give you this broader example, real example, outside of our labs, and that is when we were at Share, we had somebody that came up to us at our booth and then also followed up at our Lunch and Learn and said, well, where were you guys 3 years ago? He goes, what you guys can do with SchemaLink in just a few minutes took my team 3 years to do in preparation for the California Consumer Protection Act, the CCPA mandate that was out there. He and his team spent 3 years, Spencer, mapping data sets just so that they could then scan those data sets for sensitive data, which is extraordinary. So when you think about this, if you were talking about the cost of having, and I think he said he had about six people on his team that were responsible for this project. You take those 6 people earning about $200 an hour at 280 hours a year. You're looking at about a little over, close to about $1.5 million annually, right? So you multiply that by 3 years. I mean, you're over $4 million just to complete this project. And think about this: you're not doing anything else with your time, right? You're not writing new applications. You're not doing other things that you need to be doing. So 6 guys spent 3 years on this project. SchemaLink can do this in just a few minutes. And if you want to, think about using contractors, right? They charge a little bit more money than a standard full-time employee. So you go from $200 an hour to about $250 to $275 an hour, and now you start looking at a 3-year project, closer to $9 million. Again, SchemaLink. I kind of joked about it before, but it's kind of like these magic beans. It just removes significant nuanced work and puts the burden on SchemaLink to do all the hard work that your engineers had to do before. So just SchemaLink alone is, just the ROI alone for using SchemaLink is certainly worth the product's price, but at the same time, it's just an extraordinary achievement, and being able to do what we do again is grueling engineering, but it's also brilliant work by the team. Very proud of them.
No question. Historical achievement, impactful achievement, and clearly not only a major time saver, obviously the ROI is through the roof. So let me summarize this. We have time here. This is kind of our last question here. We have time for here. I got to get you back to all this great work you're doing on PK Protect for ZOS. So with the SchemaLink technology, because it does accurate, sensitive data discovery on the ZOS data sets, and the way that we achieve this precise or accurate, however you want to, you've mentioned it a few times, scanning capability is through data definitions like a COBOL for those mainframe folks out there, for like COBOL copybook that are magically found with SchemaLink. And I just want to make sure that I'm getting all that right.
Yeah. That's exactly right, Spencer. It's pretty much so it. I use this analogy a lot. I kind of laugh at it, but it reminds me of SchemaLink Technology with PK Protect. It reminds me of one of my favorite movies with Michael J. Fox. It came out in the 80s called Back to the Future. And there's this one thing that they keep harping on about that what makes time travel possible. And it's not the DeLorean. Of course, the DeLorean was very important part of it, but it's the flux capacitor that made time travel possible. And so I'm going to offer this analogy up and saying that SchemaLink is kind of like our flux capacitor. You cannot do accurate, precise, sensitive data discovery on PII data on the mainframe, on unstructured streams of binary data without SchemaLink. It's what makes it possible. So it's like I said, it goes out there and it magically finds all those data definitions for all those data sets on your mainframe, stores all those schemas in a runtime database that gets used during the parsing and scanning process. And in the end, Spencer, it makes for absolutely incredibly accurate sensitive data discovery scans that again will bring significant confidence to those audits. And certainly in the end, it's going to make your customers, your beneficiaries, your employees, everybody feel more confident in the organization when they know that sensitive data has been not only located, but locked down.
That's beautiful. And we start talking about the flux capacitor. I mean, we got to get. I mean, I don't know if Michael J. Fox is listening in right now, but for all you '80s folks out there, the flux capacitor. If we're like the flux capacitor, I mean, this business is going to be like a unicorn rocket ship because of this platform, Tate. Appreciate that analogy for sure. I appreciate that analogy and appreciate all the great work. You mentioned it yourself. What a great team you have in that trench, putting this together with the SchemaLink technology, the flux capacitor of the. We got to get that. We're sort of Sarah Fellner. We got to put that on the. I don't know if Back to the Future patented that. We got to put that in the website. It's our flux capacitor for the PK Protect ZOS. You heard it right here on the Triple P podcast, the Productivity Protected podcast, with your very own Tate Hamill, who is here as our director of product management on IBM systems platforms. Really the tip of the spear on the ZOS platform. For all of our mainframe partners and customers out there, I know you're chomping at the bit to get your hands on this. Many of you already have. Thank you for those who already have. For those who have not yet, let's reach out to us. Tate can help you. I can help you. We get people to help you get this, as I mentioned before, a historic technology breakthrough for us. And like Tate mentioned, 3 years plus in those bit mines with our folks in those trenches, in those labs, doing the research and the hard work necessary to make this breakthrough. Congratulations, of course, to you, Tate, and to the whole team. And again, thank you for carving out. I know you're a busy guy. Thank you for carving out time to be on our Triple P here. It's great to have you. Great to see you in the holiday season. Want to wish all of our customers and partners out there, as I mentioned, Merry Christmas, Happy New Year, a safe New Year. Most importantly, a lot of craziness going around in the world. We need to make sure we're safe with family, enjoying these moments together during this time. We've got a very, very special guest on our next Productivity Protected podcast. I'm of course never, as you all know, those who've listened to the 20 plus episodes we've already done, I've never disclosed not one time, who that next special guest. You have to actually show up at our podcast to figure out who it was. Today it was Tate. Tomorrow it'll be someone else. I'm your host, Spencer Kupferman. Don't turn the channel here. Leave it on the PKWARE Productivity Protected podcast. That's right, ladies and gentlemen. All things mainframe right here with your very own Tate Hamill. It's been real. It's been awesome. Thank you for being here, Tate.
My pleasure. Certainly an honor. And, don't wait so long next time, Spencer. I love to get up and jump up and down and talk about this technology. So looking forward to heading to Share in March and spreading the good word again. And lots of pit stops at our partners for demos and lunch and learn. So we've got an exciting 2024 coming up.
Beautiful. Appreciate that. I'm excited for it too. For Share, you heard it, Share in March. Come see Tate. Tate will tell you about everything we're doing here and then some. Appreciate everybody putting this together and getting you on here. And I apologize it's taken us so long to get you on here, Tate, but you're always welcome back here. And thank you to all of our listeners out there. Have a great, safe, and happy holiday season. Again, I'm your host, Spencer Kupferman, the CEO of PKWARE. It's a pleasure to be part of this. Thank you so much. Everybody have a great one. Take care.
Thanks for joining us on today's episode of Productivity Protected. Learn more about how PKWARE protects data and workflows by visiting pkware.com, and join us next time for more insider info on protecting data wherever it lives and moves.